Let's talk about why care about code quality in this presentation. All of us have dealt with quality at different levels in software development. In this presentation, we'll talk specifically about code quality, the ability for us to be able to understand and maintain the code that we have to develop in applications. Well, let's talk about what's quality. Quality is a measure. It is a degree of excellence, as the dictionary says, of some level of standard that we expect. In terms of code quality, we are talking about quality as a way to measure our ability to understand the code, whether it is maintainable. It is something that we are able to work with as we move forward in evolving the design, fixing bugs, and making enhancements. Now, when it comes to code quality, we have suffered through poor quality of code in a lot of different projects in our industry. But why should we really care about code quality? In spite of all of that, it's good to ask that question, why do we care about code quality? I think I have a very simple answer for it. And the simple answer is we care about code quality because we really cannot be agile if our code sucks. Well, you're at work and you're being told that you're on an agile project. And everybody says, well, that's great. That means you can respond to change, right? You're sitting at the office and your customer or business analyst is talking to you about a particular potential change. The customer or the business analyst says, hey, how about making this enhancements to the product that you have on your hand? And as you're thinking about it, you realize that the last time you touched that code that you would have to touch for this change, you could not go home that evening or that weekend. Heck no. You're going to try to convince that this is not a feature you want to implement. So, in other words, if the code is of very poor quality, we cannot respond to change. The code sucks us in, beats us down, and chews us out. So, we definitely don't want to deal with such code. And because we don't want to deal with such code, it's very difficult to be responsive, to embrace change, and to be able to go through that feedback cycle. So, a lot of things fail miserably in our ability to respond to change and be agile. But what about maintainability of code? We all have worked on projects where we start the project, everything is fun for the first few weeks, but after a few months into the project, the code has suddenly turned into a monster. And this monster is causing havoc. And we throw more programmers, more people into it. We try to tame it down. We debug through it. It becomes really horrible. But bugs keep coming. If you look at projects, there are huge number of bugs listed on projects. Where do these bugs come from? And when we start fixing those bugs, we find it very hard to understand the code and fix it. And when we do, more bugs creep in after we fix these code. Why do these things happen? Talking about maintainability itself, there is a reason why we should care about maintainability. Let's talk about that first, and then we'll talk about some consequences of poor quality code. When it comes to maintainability, I have a very good code to refer to. It's from Abelson and Sussman. It says, programs must be written for people to read and only incidentally for machines to execute. In other words, programs are read more often than being written. We are very eager to write code often, but we have to pause for a minute and think about not just writing this code, but what's going to happen when others have to read this code. If we think about that, would we want to name our variables as A, K, and W? Or do we want to give meaningful names like account, for example, or calories, or whatever, watts? The point really is we can take a little bit more extra time to think about how do we name our variables? How do we name our functions? Is the code readable? Is the code understandable? Is the flow of logic really nicely laid out so people can understand what we are doing? Are we writing code that is self-descriptive? Or are we making the code cryptic? We can think about a lot of these things if we keep in mind that our code is going to be read more than being written. So, given that, what are some of the consequences of writing bad code? Like I mentioned, most of us suffer through bad code, but fortunately, our code doesn't appear in the media. But other people are not so lucky. Let's take a look at some examples of that here. So one of the magnitude of these problems is that, to name one example here, the European Space Agency took 10 years, really 10 years, and $8 billion to develop the Ariane 5 spacecraft. To add insult to injury, they added a voyage, on the first voyage, they added a cargo worth $500 million. Within the first 40 seconds of the flight, they found that the system started malfunctioning. The spaceship turned around and started going towards ground rather than going up into the space. So at the end of the 40 seconds, knowing this is heading towards disaster, they pressed a button and blew it up. Well, if you want to have a fireworks, it should take a lot less than 10 years to build and $8.5 billion to build it. So the point really is that this caused quite a bit of problem. But what was the reason for this failure? They eventually found out that it was a result of a floating point number representation trying to be interpreted or converted into a 16-bit signed integer. It was a conversion failure that caused overflow, an unhandled exception that blew it up and caused this. Well, this was deliberately destroyed, but is this a preventable error? What could we have done to make the quality of code better, to handle the errors better, to look out for these things so that we could avoid such major failures? If this was one incident, a very standalone incident, we would say, yeah, bad luck. But there are several other examples. We already know it on our own projects. But just to refer back to other things that are in our visible eyes in the media. Back in 1999, there was a mishap caused by units of measure conversion from kilometers to miles that led to the NASA orbiter crashing. Also, Nike had a forecast system that ordered a huge number of shoes, much more than inventory really needed, due to an error in computing. There was another NASA glitch that killed the Mars rover. And I remember this day in 2007 when a lot of United flights were canceled because of a computer glitch. And the story continues on and on and on. So we have seen a lot of these consequences of poor quality of writing software, poor quality code, not having good discipline, not practicing certain set of techniques, and yet our entire industry is in denial about it. We talk about poor quality, but we need to do something about it. What can we do to create better quality code? I want to talk about this topic in a series of presentations. I want to talk about what can we do as an individual? What can we do as a team? What are some of the tools and techniques and practices we can use? But of course, all the talking will only help if we do something about it. Over the past about 5 years, I've realized that I've been writing really crappy code. And I've made something different about it. But there's a reason for the difference as well. I am developing more and more software for myself, for my company. And it is my personal money that gets wasted. I'm not here to tell you that I don't care about my other companies' monies that I worked in other companies. I do. But I'm becoming more sensitive as my own personal money is invested into the products that I'm building. And so, yes, I do have good standards and I want to implement them when I work for other companies. But I uphold to a greater amount of standard for my own company, for my own products, because when things fail, it's my pocket that gets drained. Well, what if we all think about this every day we write software? Or what if it's like our money, our failure, our systems, our inconvenience, and our lives? We as profession need to get better at developing software. We will talk about some of the ways we can do, but I hope we can also practice and change whatever way it is, incrementally, really at large scale. I don't really care. But if we go towards a better software development, I think we have done something better for ourselves and for our profession as well. So let's talk more about software quality and discuss some of the ways as individuals and teams we can do better in the next series of presentations on this topic.